Quantum supremacy is a term used to describe a milestone in computing where a quantum computer performs a specific task that would be practically impossible for even the most powerful classical computers to complete within a reasonable time. It does not mean that quantum computers are superior in every way, nor that they will replace classical computers. Instead, it marks the moment when quantum machines demonstrate a clear advantage for at least one well-defined problem. To understand quantum supremacy, it helps to recall the limits of classical computing. Classical computers process information using bits that are either 0 or 1. Even with massive processing power, classical machines must still evaluate problems step by step. As problems grow more complex, the number of required calculations can increase exponentially, quickly exceeding any realistic computational capacity. Quantum computers operate under different rules. They use qubits, which can exist in superpositions of 0 and 1 at the same time. Multiple qubits can also become entangled, creating correlations that allow quantum systems to represent and process an enormous number of possibilities simultaneously. This does not mean that quantum computers try all answers at once, but it does mean they can explore complex computational spaces more efficiently for certain tasks. Quantum supremacy refers to a carefully chosen problem that highlights this advantage. The problem is usually designed so that it is extremely difficult for classical computers, but naturally suited to quantum systems. Importantly, the task does not need to be practically useful. Its purpose is to demonstrate that a quantum computer can outperform classical machines in principle. The term became widely known in 2019, when researchers announced that a quantum processor had completed a specific calculation in minutes that would take classical supercomputers thousands of years. The task involved generating and sampling complex quantum states, something quantum hardware does naturally but classical systems struggle to simulate. This announcement sparked debate. Some researchers argued that classical algorithms could be improved to reduce the time gap. Others pointed out that even with improvements, the classical approach remained vastly slower. This debate is a normal part of scientific progress and does not invalidate the core idea of quantum supremacy. It is important to understand what quantum supremacy does not mean. It does not mean that quantum computers can solve all problems faster. Many everyday tasks, such as word processing, web browsing, or basic arithmetic, will always be better handled by classical computers. Quantum machines are specialized tools, not general replacements. Quantum supremacy also does not mean that quantum computers are mature or reliable. Early demonstrations of supremacy use noisy, error-prone devices operating under highly controlled conditions. These machines cannot yet run long, complex algorithms with practical value. The achievement is more like the first powered flight than a modern jet airplane. The real significance of quantum supremacy lies in what it proves. It confirms that the laws of quantum mechanics can be harnessed to perform computations beyond classical limits. It shows that building scalable quantum hardware is not just a theoretical dream, but a practical possibility. From a scientific perspective, quantum supremacy is a validation of decades of theoretical work. Physicists and computer scientists predicted long ago that quantum systems could outperform classical ones for certain tasks. Supremacy experiments provide experimental evidence that these predictions are correct. From a technological perspective, quantum supremacy acts as a catalyst. It motivates investment, accelerates research, and pushes the development of better qubits, improved error correction, and more useful quantum algorithms. Each step forward builds on the previous one. There is also a strategic dimension. Quantum computing has implications for cryptography, national security, drug discovery, materials science, and optimization. Demonstrating quantum supremacy signals that a country or organization has reached an advanced level of technological capability, even if practical applications are still years away. Looking ahead, researchers now focus on what comes after quantum supremacy. The next goal is quantum advantage, where quantum computers outperform classical ones on problems that are not just hard, but genuinely useful. This includes simulating molecules, optimizing complex systems, and improving machine learning models. In simple terms, quantum supremacy is the moment when quantum computers stop being just theoretical and start doing something classical computers cannot realistically do. It is not the end of the story, but the beginning of a new chapter in computing. Quantum supremacy reminds us that computation is not only about faster processors or smaller transistors. It is about the fundamental rules of nature that govern how information can be processed. By tapping into quantum mechanics, we are exploring a new frontier of what is computationally possible. As quantum technology continues to evolve, quantum supremacy will be remembered as a historic turning point. It marks the transition from promise to proof, showing that quantum computers are not just an idea, but a working reality grounded in the strange and powerful laws of the quantum world.